Hey everyone, welcome back to the Curly Boy Theatre. I am Lily Ryan, your MC. I'll be here all day, so if you've got anything, just shout out and I'll be here. Right, okay, next up we have Shivashis Padhi, who is going to be talking about what happens behind execution of an import statement. Hey, how are you going, Shiva?
I'm doing all right. How are you, Lily?
Yeah, I'm doing okay. So Shivashis is a senior majoring in computer science and engineering at NIT in Trichy in India. With 3 years of experience as a student software developer, he's worked with multiple organizations, large and small scale startups. He lives by a simple policy: learn and build stuff to make the world a better place. He's currently an intern with the data engineering team at Grofers, building geospatial data management tools. He spends some time contributing to MSS with an amazing set of people, and we're very happy to have you here today with us to talk all about import statements.
Thanks, Lily. It's good to be here, actually. And I hope everybody in the conference is doing well and okay and staying safe. And we can start with the talk.
Excellent. Let's roll it.
Okay, hey everyone, I'm Shivashis and today we're talking about the import system in Python. Before that, a little bit about me. I do data and software engineering at Grofers, and in my spare time, I tinker with Earth observation data, and I was a GSOC student last year with the PSF, and I love open source software. I worked on a couple of them. Before we start with the talk, there's always a relevant XKCD. In our case, it's the Python XKCD. It talks about how easy everything is in Python. And for relevance, there's a nice import statement in the bottom frame. Okay, let's start with our talk. So what are packages in Python? Packages are the directories? No, not necessarily. Packages can be something really abstract, as in you have a bunch of CSV files and you tweak your import system in Python to understand it, then the whole thing can be a package as well, right? And they're just special type of modules. Modules for our understanding can be as simple as a simple Python script which has a bunch of classes and function. That can also be a module, right? It is just a special type of module with a path attribute which tells us where did we find that package. And sub packages are packages within packages, right? So if you try to do from spam import ham, ham should ideally be a sub package of spam. This is a sample directory structure in where there is a directory called spam, and inside it is a components.py file. And this has some variables, and in the same directory, if we spawn a Python shell and try to import x and print x, it works. But how can we import this module spam from a different directory, right? That's where path and PyThonPath come in. So if you append the parent directory of your package to these variables, system-wide variables, then you'll be able to import them from a different directory as well. We'll see how that works later. But for now, if you append spam's parent directory to Python path, it should ideally work with, even if you try to import it from different directories in your system. Okay, so let's talk about different types of packages here, like regular and namespace packages. Regular packages are the primitive type of packages supported in Python, as in you have to put an init.py file in your package, and then you can import everything inside it as a sub package from a different directory or wherever you're trying to import this package spam from. However, with namespace packages, you can put parts of your package spam in different locations in your OS or anywhere, but you have to put these packages in Python path or the parent directories of these packages in Python path, and then when you try to import this package, for example here we do from spam import package 1, then you'll be able to import everything, components 1 to any chunks you put in Python path, right? Even here, if you try to log spam.path, you get a namespace path, and then you see the different directories you imported spam from. These are namespace packages. These are some packages supported by default by the Python import system. They are built-in modules like sys, os, etc. Frozen modules, basically if a module is frozen for your OS and setting, and path entries, whatever is in path and Python path can be inherently supported by the import system. Let's talk about the import system. We talked about packages and how to make them importable, and let's talk about the import system, how what happens when you try to import that package from somewhere. These are some components of the import system which we talk about in phases. The first of it is sys.modules. Think of sys.modules as a dictionary which maps the module name to the loaded module. So when you try to import something in runtime, there is a reference to the module in sys.modules. It lives in the global namespace of sys, and this is something you can experiment yourself. Like if you try to import sys and check if sys in sys.modules, then you get true. Request you haven't imported yet. So if you try to check if it is in sys.modules, you get false. When you try to import request, and after that, request is in sys.modules, right? Okay, let's now talk about importlib. Importlib provides the implementation of the whole import statement or how it is handled by the import system, right? So every part of it is exposed through importlib. If we try to replicate the import system, we can ideally be able to do it with the help of importlib. Even to tweak the import system, the parts we patch it with, we will use importlib to do that, or the fancy term for it being import hooks. We'll talk about this later. These are some common use cases of importlib. Even when you don't want to tweak the import system, you can do some tasks with it. For example, you don't want to do import spam for some reasons. Then you can do something like spam equal to execute a function from importlib called importlib.load module, right? And then in arguments, you give the module name called spam, right? It will load the module for you. And then reloading a module in runtime. For some reason, if you have changed the module which you have tried to import or imported in the past, and you want to reload the module, importlib gives functions to deal with this. And the most important is it gives base classes for finders and loaders to be used with import hooks. So to build import hooks or to tweak the import system, we have to use custom finders and loaders. We don't know what they are, but we will use it. So importlib gives these base classes for us to inherit and use it. Okay, in the last slide we talked about finders and loaders. Let's now talk about them. Okay, finders. Finders, they stand true to the literal sense of meaning, as in they just find things. What? Find what? You ask. Okay, so when you do import something, the Python import system parses it and it goes to these finders and asks them, hey, can you find this module for me? And by find, I mean just find. Don't load them, don't do anything. Just tell me if you can be able to find it for us. Okay, so if a finder can find a module, it returns a spec object, right? Well, spec object, okay, we'll talk about spec object next, but if a finder can find a module, it returns a spec object, and every finder must have a find spec method defined. So what ideally the import system does is it goes through every finder and executes this find spec method and tries to get the return value from it. These are some default finders which we have in Python's import system by default. They are to locate built-in module, and we discuss what built-in modules are, and to locate frozen modules, and to import whatever is in path or Python path. They are all different finders which will be executed in sequence to find a module. Okay, so what are the functions of a finder? If a finder is capable of handling an import statement, it returns a module spec, right? We know this from this slide we saw. So what is a module spec? A module spec contains the module's metadata, as in the path, name, etc. And the import machinery then uses it to load the module later on as well. So after this, after metadata is returned, along with the spec, a loader object is also returned. The import system uses this loader to load the module later. Just know that finders don't have to do anything with loading the module, right? The import machinery, it controls everything, and until now we just know that it knows how to find a module. So this is the find spec method I talked about. This is a dummy example which checks if a module is built in, as in if it is something like types or sys, etc. If it is, then it returns a spec and a loader, right? You can see here, it returns a full name and loader object and makes it a spec and then returns it. If it can't find it, it returns none. Okay, to import sub packages like spam, like importing ham from spam, we have to find the parent packages first, right? We have to import spam first and then spam.ham. This is done because let's say in your ham file or ham sub package, you are trying to import spam and spam doesn't exist. So you do it recursively and you cannot exit the loop. So that's why the parent packages are imported first, and then sub packages and gradually. So if you're trying to import C from A dot B, then A has to be imported first, then A dot B, then A dot B dot C. Okay, that's done. Let's talk about import hooks and PEP 302. These are some more components of the import system which we should know about. So we know what finders are, right? So they help the Python's import system or import machinery find a module. So sys.metapath is a list of finders which the import system checks while finding a module, right? So it is a list and it has some finders. What the import system does is it goes through this list and checks with every finder, hey, can you find this module, right? And if one of them returns a spec, then that's it, the finding is complete and next steps are executed by the Python's import system. Else it goes on checking like until some finder returns a spec. Path hooks, however, they're used internally by the pathfinder object in sys.metapath. They're used to find file related objects as in zip files or tar files. You can extend the import system to do these as well. Okay, this is an example of sys.metapath and sys.path hooks, right? So as you can see, sys.metapath had some built-in importer, frozen importer and pathfinder, right? And path hooks has zip importer and file finder. These are to find zip and normal .py source files. Okay, so what are import hooks? Import hooks is this fancy term to tell about the feature where we can build our own custom finders and loaders and we can inject it to Python's import system, and every time Python's import system tries to find a package or load a package, it checks with our finders as well, as in the custom finder which we hook to the import system, right? So it looks a lot like dependency injection, maybe it is, and it's as simple as like loading the custom finder object to metapath. We can just append it, and every time an import happens, it checks with our custom finder object as well. Okay, let's talk about loaders now. So before that, let's take a step back and gather everything we've known so far about the import system, right? So we have something like sys.modules, which is a dictionary which maps a module name to the loaded module in runtime. And we have something like sys.metapath, which has a list of finders, which the import system goes through while importing a module, right? Or try and find a module. Okay. So remember when I told you that a finder returns a spec and the spec object has a loader which will be used later to load and execute a module? Here we are, these are loaders, right? So after a spec object is returned from a finder, then the same loaders are used to execute the module and store its reference in sys.modules. These are some tasks of a loader. A loader is used to load from source or bytecode, and if it is loading from source code, then it will compile the source and it executes the module and stores a reference in sys.modules under the key spec.name. Okay, let's now talk about loading with the help of an example, right? So there is a module, we instantiate it to none, and then we check for an attribute which will be a function called create module. If there is a create module attribute, it will just create the module with all the attributes and it basically create a dummy module for us, right? If it is not defined, then we create it ourselves with module type, right? This is imported from the types library, and yep, so we create the module now, and then we initiate it with some attributes as in its path, name, what is the spec associated with it, and what is the loader, etc. Okay, so if spec.loader is none, which should ideally be the case, because we have discussed that spec must have a loader, right? If it doesn't have a loader, then we raise an import error. If it has a loader, then we check for an exec module function. If the loader is, if the loader has exec module function, right? If it doesn't have it, then it has to have a load module function, and this is basically loading the source code, or this is loading the source code and storing it in sys.modules under the key spec.name, right? If it doesn't have a load module and it has exec module, then we should use exec module, right? So we create an entry in sys.modules, we execute the module in that namespace, and if there is an exception, we raise an import error. And if we have created an entry in sys.modules, we should delete it, right? It shouldn't have a faulty entry. Okay, so after that, we return the entry we created in sys.modules. Okay, what are some errors which we encountered during the whole import system, right? So we encounter ModuleNotFoundError when there are a list of finders in sys.metapath, and every finder returns none, right? So nobody knows how to find the module. So that's true, then we cannot find the module and we raise a module not found error. And when one of the finders returns a spec, then while loading it or executing it, we hit a snag, then we face import errors. It's the import system telling you that, okay, I know where to find this, but I don't know how to execute it, right? Okay, we've discussed a lot of things so far. Let's put it in a nice block diagram and understand what happens in the chronological order. So there is Python runtime. When it parses the import statement, it tries to look for this module in sys.modules. If there is an entry, then it returns the entry which is in sys.modules. Else, it goes to sys.metapath and queries each of these finders, like executes their find spec method and checks that if any finder can return a spec object for it. If none of them return a spec object, then a module not found error is raised. If one of them returns it, then it goes forward and tries to load the module for us. And if there is an error while loading the module, we get an import error. Okay, so that's all the theory part. Let's now talk about how we can use it. So I'll be showing you a demo use case where our import hook will be able to handle import statements from a remote URL, and it will be protected by an basic HTTP auth method, right? Okay, let's jump to the code then. Okay, so here we have our file which has the finder and loader class, and then we have a test file which we will use it to test the input, and then we have 3.py. This is the final module which we will be importing from a remote repository. So we have the directory structure of the remote repository will be like this. There is test project, and inside it is a sub package called 2, and inside it is a module called 3.py, and there is 1.py, but we don't care about it. We don't import it from 1.py. And anyway, to serve it, I'm using a simple HTTP auth with basic HTTP auth with a file server, and we will start the file server. Okay, so it's starting here, and then I'll just move it up so that you can see it. Okay, so we have a file server ready. Now before we test anything, I'll take you through the finders and loader class. Okay, so what are we essentially doing is we are trying to get the finder class from importlib local, which is this file, and then we instantiate the class with a URL and the test project or the project name we are trying to import 3 from, right? And we append it to sys.metapath, and then we try the import statement. And finally, if everything goes right, we will be able to execute the function which is in 3.py. And printDummy is a function which is in 3.py, and it prints the parameter in red, right? So if everything goes right, then we'll be able to see our 5, like this is the parameter we're providing in printed format in red. Okay, I'll clear this. And imported local.py has finder which is named remote directory finder, and there's an init function to give it some settings as in URL and subdirectory where to find from. Okay, let's talk about find spec method. We said this is important, right? This will be called by the Python's import system when it is trying to find any module, and a subset of which is our test project.to import, right? Whenever this is imported, our custom finder will also be called, and this method is what will be called at first. If the full name doesn't have test project, we are returning none. That's how we are telling the import system that, oh, we don't know how to handle this import statement. And if there is test project in it, then what we are trying to do is we are printing find, okay, we found something, we found a module. This is for our use case as in how we will demonstrate it. And we are returning a module spec with the full name and a loader associated with it. So this loader will eventually be used to load and execute the module, right? Unless we provide a loader, we'll get an import error, right? Okay, so how is the loader structured then? So loader also has an init function, and these are some URL path settings, and this is a utility function to get the source code for a path. Like basically it's requesting the URL to get the source code, and the session auth is defined here. It has to be a basic HTTP auth for now. You can like experiment with the authentication you're trying to implement, and there is a create module function. The job of this is to create your module, right, in a module type object. Yeah, this is imported from types library, and you can create your module, and then, oh, this is a small check to check if there is an entry in sys.modules. If there is, then we don't have to go ahead with the import statement. Okay, here we are trying to initiate some attributes of the module, as in file name, loader, spec, right? The path is a dummy path, but yeah, you can ideally, if you're trying to build an import hook, then you should make the path the remote repository path, right? So yeah, if install is true, it should be already, as in like this is a default, then we are adding it to sys.modules, right? And once that is done, the next step, if you remember from the sample code we used to show how loading has happened, then the next steps are exec module, right? Here we are trying to get the source from path, and then we are executing the source, and if there is an error, we raise an import error. And this is the namespace in which all of the variables and class names are bound. Mod.dict is the namespace in sys.modules under the entry spec.name, right? So this mod is provided by the Python's import system, and this is the same module which will be there in sys.modules. So it's executed in that namespace. So every variables and functions are bound to that namespace. And yeah, that's all of it. These are the three important functions which we should care about. I'll go through this again. You have to implement find spec, you have to implement create module, and you have to implement exec module. And that's probably all of it. We can go ahead with testing it. Okay, so it worked because we see 5 printed in red, and since both of these are different directories, we know for sure that it's not importing locally, right? And okay, so what happened here? So we tried to import this. This is what we tried to import, right? But eventually what happened is test project got imported, then test project.2, then test project.2.3, right? We talked about this in a previous slide. And what it does, it finds the module first, then it creates the module, as in the module type function. Module type to instantiate module type class, and then we are installing the module in sys.modules, and then we are executing it in the namespace which will be required later. Okay, so that's everything for the demo part. Let's now jump back to the slides and talk about how other people have used the import hooks. Okay, so what else can you do with import hooks? With import hooks, you get full control after what happens when you do import X or any import statement, right? You can import from FTP, HTTPS, or any other like S3 bucket, anywhere. You can import from anywhere, and you can put your own authorization checks, and you can not just .py and bytecode Python files, you can import from a variety of storage like JSON, CSV, go wild. Okay, so how have people used import hooks so far? So the first one is a library which parses JSON like a Python module, right? If you have a file called some name.json and you try to import name.json in your Python file, if this import hook is installed, then you can get a variable for the JSON. You don't have to parse it manually. So this gets useful when you have faulty data sets you're using within your organization, and you don't want to parse or make a parser in application code. So you just distribute the import hooks, and every time someone imports the faulty data or tries to use the faulty data, the parsing, the filtering, cleaning, everything happens in the import hook itself, right? And okay, so this is the second example is how this repository helps import from github.com. It's not recommended because there'll be dependencies involved, and your import hook has to be wise enough to resolve those dependencies, right? And the third one is a repository which helps importing from gist files in GitHub, and then IPython notebooks from anywhere, and yeah, utility functions like that. Okay, so this is something cool which I found. You can try this on your own as well, as in by yourself. So yeah, if you have your virtual environment disabled and you try to log sys.metapath, you get some default finders, right? Like built-in importer, frozen importer, etc. But if you have your virtual environment enabled, then you see your virtual environments finder at index 0 of sys.metapath. So what's going on is when you do pip install something with virtual environment enabled, then it installs the module in side packages in the virtual environment directory, right? And it doesn't go all the way up to your root side packages and installs there. It doesn't do that. So this finder object tries to find these packages in local side packages directory. If it can find it, then it will return it. It doesn't go all the way up to your root side packages. And yeah, that's how it makes your system safe. Okay, that's almost all which I had, and you can ask me questions as well. And thanks for attending the talk. I hope you have a great day. And if you have any more questions even after the session, then you can get my contact from my website and get in touch with me. So, okay, thanks.